Okay, welcome back. Let me to open my slides. Yes. Okay. So in previous lecture, we will check also process states. As I told you, process states are not something physical. It is just a kind of situation that okay, can you write your student number? Okay. So thank you. So process states are just showing in which situation is the process. Okay. So while you are working on a task, let's think. It has also some states. For example, you just started or you finished, or you are working on it, or you are waiting something from another person. So it is actually not continuing at that time. So not a physical situation, but it is explaining what is your situation logically. Okay. So we have some operations on the process. So one of them is creation. So once the process is created, it will be ready and come into the ready queue in main memory and will be ready for execution. So when it is created, so we have to just we have to consider that it is in ready queue and it is ready for execution. So you will see after a few slides. By the way, we are going deeper and we are seeing much more details after seeing more slides. That's why when a process is created, it is come into the ready queue. So if you remember ready state, so to enter that state, we are understanding that there is a queue. So think about that. Memory is not empty, or sorry, memory is full, and but still wants to enter there. So you should be in a queue in this case. So this is ready queue. So process creation in just I'm coming. Someone is asking question, I think. I'm trying to. Okay. If you have a question, please write to chat. I'm following now. Okay, process creation is just done by using the command fork. We will see this one. This is a kind of function that when it is written, it is creating a new process. So we are showing the operations on the process. Okay. The second one is scheduling. No, I will upload today this topic. Okay, someone is asking if I uploaded it to Moodle. I'm going to upload it today. Okay, scheduling. Out of the many processes present in the ready queue, the operating system chooses one process and starts executing it. So in the ready queue, there are many processes present. But operating system, according to some rules, chooses one of them and executes it. So selecting the process which is to be executed next is known as scheduling. Okay, so to say this one will be executed next, which this one is selected, is scheduling. So this one is actually showing the situation of the system in more detail. So ready queue is actually inside RAM or main memory. Okay. Job queue is actually the processes that are waiting to enter the ready queue. And one process is taking each time, and CPU is executing that. So the selecting a process and executing this is known as scheduling. Okay. Execution. Once the process is scheduled for execution, the processor starts executing it. Process may come to the blocked or wait state during the execution. Then in that case, the processor starts executing the other process. So while it is executing, as I told you, a process may need some input-output operation. So CPU will take that one away and pick another process from ready state or from main memory. Okay, this is execution. Last one is deletion or killing. Once the purpose of the process gets over, so it means when it is finished execution, then the operating system will kill the process. Why? Because it is not needed anymore when it is finished execution, and it will waste resources if it is not deleted. So the context of the process control block will be deleted, and the process gets terminated by the operating system. So this is another operation. So we have four main operations: creation, scheduling, execution, and deletion of the process. Okay. So we have some schedulers for the process. So scheduler is not only for running state, ready state to running state. We have three kinds of schedulers. One of them is long-term scheduler, the other one is short-term scheduler, and the last one is medium-term scheduler. We have three schedulers. So not only for, take one process from main memory and execute by CPU. This is not only scheduler that operating system have. Okay. So the ready queue, we have the processes that waiting for execution. Let's say. So from ready queue, if one process will be picked by CPU and execute, it should short-term scheduler is in charge. And the dispatcher is a mechanism that it is assigning it to CPU or the midterm scheduler. So short-term scheduler says, okay, this process will be execute next. And this is done by the help of dispatcher. Let's take it one by one. The long-term scheduler. It is also known as job scheduler because the jobs are at that time are in hard disk, secondary memory. And by the use of long-term scheduler, they are sending to ready queue. It is a situation that takes from secondary memory the program and put them into main memory as program is becoming to process. So it chooses the processes from the pool which it is in secondary memory and keeps them in the ready queue maintained by the primary memory. So they are putting them into ready queue. So long-term scheduler is responsible from taking the jobs from hard disk or secondary memory and put them into the ready queue. And long-term scheduler mainly controls the degree of multiprogramming. If you remember the first lecture, I explained about CPU burst or input-output burst processes. So CPU burst means much time is spending in CPU for execution. Input-output burst is much time is spending for input-output operations. So what does this mean? The CPU burst processes are needs CPU more. Input-output burst processes are needs the other input-output devices more. Of course, both of them are using CPU, but input-output bound processes are using less. So the to put the operating system to put the ready queue while putting the processes into ready queue, operating systems should consider this too. It is trying to balance the two kind of processes. So while CPU is working on something, on the other hand, another process can do input-output operations. So in this case, we will use the CPU efficiently. So this is the controlling the degree of multi-programming. So the long-term scheduler is responsible for that. So the purpose of long-term scheduler is to choose a perfect mix of input-output bound and CPU bound processes among the jobs present in the pool. So if the job scheduler chooses more input-output bound processes, what does this mean? Then all the jobs may reside in the block state all the time, and the CPU will remain idle most of the time. So input-output bound processes, if we have several input-output processes, the processes will be always trying to make some input-output operation, and CPU will be idle most of the time. And this will reduce the degree of multi-programming. Degree of multi-programming is if you can put more processes in the main memory, it will increase the degree of multi-programming. But these kind of things are affect the efficiency. Therefore, the job of long-term scheduler is very critical and may affect the system for a very long time. So the aim of naming them long-term scheduler is actually, it is a kind of, you are giving a decision for future, for a long term. Okay. Short-term scheduler is known as CPU scheduler. It selects one of the jobs from the ready queue, and it is dispatched to the CPU for execution. So this is the task of short-term scheduler, and it is so-called CPU scheduler. This the task of this scheduler is very critical, that if it selects a job whose CPU burst time is very high, then all the jobs after that will have to wait in the ready queue for a very long time. Look, let's say this is process 1, this is process 2, this is process 3, and process 4. Okay, so let's say the execution time of process 1 is 5 nanoseconds. P2, let's say 2 nanoseconds, P3, 4 nanoseconds, and P4, 40 nanoseconds. Okay, if the CPU, if the short-term scheduler selects this one for execution, what does this mean? This one will run 40 nanoseconds, and this tree should wait for it. Okay, so they should wait so long. And this is called starvation. So the task is very important because the others should not wait for you so much time. Okay, let's continue. The other one is medium-term scheduler. Medium-term scheduler takes care of the swapped out processes. So swapped out, swapped in means when you move something from main memory to secondary memory, it is swapped out. When it is come back from secondary memory to main memory, it is swapped in. So if the running state processes needs for some input output time for completion, then there's a need to change its state from running to waiting. We discussed it in last lecture. It removes the process from the running state to make room for the other processes. So if it is not be executing, and it will need to wait for some input output operation, in this case it is not necessary to remain in the main memory. Such processes are swapped out processes, and this procedure is called swapping. So it is moving them into secondary memory. So this is primary, let's say primary memory. But while it is executing, when a process needs for some input output operation, midterm scheduler is putting it to waiting queue, which it is in secondary memory. Okay, so of course when it is finished its input output operation, again by the midterm scheduler will be put into the ready queue again. So this is medium term scheduler. So the medium term scheduler is responsible for suspending and resuming the processes. So when it is has to wait, it is take to suspending, and when it is finished its operation, it is resume. Okay, so the swapping is necessary to have a perfect mix of processes in the ready queue. So also they are making swapping for sending them to hard disk, secondary memory, or taking them back. Okay. Okay. So while we are explaining the schedulers, we also talk about the queues, but here we will see them in more detail. The operating system manages various types of queues for each of the process states. The process control block related to the process is also stored in the queue of the same state. If the process is moved from one state to another state, process control block is also unlinked from the corresponding queue and added to the other state queue in which the transition made. So it is just saying we are updating the process control block according to which state is the process. Okay. The job queue. Also, you can consider, I mean, job queue is here. This is ready queue. This is waiting queue. The images are different, but they are more or less same. So do not confuse it. In starting, all the processes get stored in the job queue. And it is maintained in the secondary memory. So when they are in job queue, they are in secondary memory. And the long-term scheduler picks some of the jobs and put them into the primary memory, which ready queue is inside primary memory. Ready queue is maintained in primary memory. The short-term scheduler here picks the job from the ready queue and dispatch it to the CPU for execution. When the process needs some input-output operation, it means that maybe a process may not need it, may never need it. So we are not going to have this situation if it is not needed. Maybe it will execute it and finish the execution. But if it needs some input-output operation, in order to complete its execution, operating system change the state of the process from running to waiting. So when it is goes this part, it means your state is not running anymore. It is waiting state, in waiting state. So the context process control block associated with the process gets stored on the waiting queue, which will be used by the processor when the process finished the input-output operation. So in this case, it will go to the waiting queue. Okay. So this is how we are using, or how the operating system is managing the processes. Okay, we have so many things to remember, but After that, CPU scheduling. I think it is, or let's talk about it. It is, so while we are working on this system, it is just calculating all the times. I mean, when the process arrived into ready queue, how much time it spent there, when, how much time it spent to execute. Think about that again in a barber shop. You arrive there at 2 o'clock. The barber took you at 2:30, and he finished cutting your hair at 3 o'clock. So totally, you spent 1 hour there, but the execution time is 30 minutes. So all these things will be shown similarly in execution of the process. So the arrival time, by the way, arrival time is that we are just counting, for example, the starting of a process or something like that. We are starting at time 0, and according to the execution times, burst times, we are calculating the time. Okay, so we are using a timeline for the this kind of situations. So arrival time is the time at which the process enters into the ready queue. So when a process enters to ready queue at time 3, so it means a process is in ready queue at time 3 here. So this is called arrival time. Okay, for now, forget about these images. I will explain you. The burst time, the total amount of time required by the CPU to execute the whole process is called the burst time. So how much time CPU needs to execute that process? 5 nanoseconds, 10 nanoseconds. It is called burst time, okay? And burst time is not include the waiting time. What is waiting time? Process maybe wait for a while until the CPU take it. Okay. Now, by the way, this is an information. It is confusing to calculate the execution time for a process even before executing it. Hence, the scheduling problems based on the burst time cannot be implemented in reality. Actually, normally, we can just can guess it, how much time it is needed. But it is much more complicated in reality. Completion time, when it is completed, I mean, when you finished your haircut in barber shop at 3 o'clock, this is completion time. Okay, so the time at which the process enters into the completion state or the time at which the process completes its execution. So this is completion time. Turnaround time. You arrive to barber at 2 o'clock, you quit at 3 o'clock. He didn't cut your hair in 1 hour, but you wait there. So the time that you hang out there, it is your turnaround time. So the total amount of time spent by the process from its arrival to its completion is called turnaround time. Okay. And waiting time, the total amount of time for which the process waits for the CPU to be assigned is called waiting time. In barbershop, you waited half an hour. So it is called waiting time. Okay. Yes. Response time, the difference between the arrival time at the time at which the process first gets the CPU is called the response time. So so it is in time. So when you come at 2 o'clock, when CPU is when the barber take you at 2:30. So the difference is your response time. So we will see them in more detail. Just check them as theory. So we will have some algorithms related to them. So you will learn it very well. Okay. So these are the various times related to the process. I took your attendances. So I'm going to finish the lecture. If you don't have any question, next week, I hope means it will be face to face, and we will continue face to face. So I will also upload the lecture notes and the recordings to the Moodle. So if you don't have any question, if you want, you can text to me, or I can just open another connection and continue. Okay.